Hi, good morning. Today I am going to give a lecture on friction. That is the second part of friction actually. In my first lecture, I discussed about what is friction and so in my first lecture, I discussed about what is friction. Okay. The next is different types of friction. In our today lecture, I am going to tell you about application of friction. And AKTU question based on friction. Okay, these are some things that I discussed before and now today I will discuss. Okay, the first thing is friction. What is friction? Simply in two words, it is a resisting force, right? It is a resisting force. You can say that if there is a two bodies, okay, there should be two bodies to create a friction. Okay, you can say that two bodies in contact. Okay, these two bodies are in contact. That means there should be some friction against motion. Okay, if this block is tried to move on this side by some force, that is P, that means there should be some friction that will resist this force, that is, you can denote it by Fs, and the value of this is simply mu n. Mu n, this time it is mu Sn. If the body is in rest, this is mu Sn. If the body is in motion, it is mu Kn. What is mu S and mu K? In my first lecture, I described about it is static coefficient of friction. Okay, and the mu K is kinetic coefficient of friction. Okay, kinetic coefficient of friction. Kinetic used when the body is in motion and static used when the body is in rest or at the verge of motion. What is the verge of motion? That means a body is just about to move. That means it is at the verge of motion. A graph you can make here, like this is a force, this is an external force that I applied on any particular body, like this body I applied a force P, and a resisting force, that is friction, is try to work on this. Okay, now if I increase the P like 1 kilonewton, but okay, the body weight is something 10 kg and something, I apply 1 kilonewton, it will resist. Okay, 1 Newton. I again applied 2 Newton. Okay, increase the load and the friction is increased 2 Newton. At the same time, I see that the body have enough friction. Now the body is in the verge of motion. Okay, when the body weight is contracted by friction force, at that time body is at the verge of motion. That means the friction at its max limit. Okay, friction at its max limit, like it is in at 3 Newton, it is at max limit. So this will make a linear. Okay, at this time the friction is used is mu s. Okay, now at the verge of motion. Okay, now after crossing F max x, what happened? It will create kinetic friction, or you can say that the body is in motion. Now the working coefficient friction is mu K. Okay, if I can, sometime example of for this is about a cycle. You can take an example of cycle. When I start cycle, I have to provide a lot of force, but when it is in motion, I'm not going to provide that much load, that much force, but my cycle is in motion. Okay, so I can say that the mu K value is less than mu S. Is it right? Of course right, because in the motion timing, you don't need to apply a lot of force, but to start a motion, you need to provide a lot of force. Okay, so I can say that approaching the F max, the force is intensely reduced, right? The force is intensely reduced because the body is in motion now. Now it will move like with the coefficient of mu k. Okay, so this graph is going to like this, and this point is called verge of motion. This is also sometimes known as impending motion. Impending motion is what? When the body is just about to move, that motion is called impending motion. Okay, so these are the things that I discuss about friction. Now the type of friction is simply, it is static friction, kinetic friction, rolling friction, fluid friction, a lot of types that I discussed in my previous lecture. I'm not taking a lot of time in this. Now I'm going to describe the today lecture, that is application of frictions. Application of friction is, okay, application of motion, that means where the friction is used, like I can say that in ladder. How can I say that friction is worked? See the diagram of ladder. This is a ladder. Okay, this is supported by a wall. This is our wall. Okay, this is our surface. Okay, and this is a ladder. This is a ladder. This is supported by this. Now we know that if the load is increased, this ladder will slip down. Okay, this ladder is slipped down. Okay, if this ladder is slipped down, at how much instant this ladder is not slipping, that means there is some force that is resisted this force, right? Like I apply a person here, and the ladder is not moving. Okay, now this person take second step. This is here. Now the ladder is now not slipping. Now the person is there. Okay, and this time ladder start to slip. Okay, that mean that much friction the ladder will carry. Okay, that's why the ladder is not slipping before this. Okay, but the person is he is going to upper side, the load is increased, the movement is increased. You can say that this time the force multiplied by this distance, the movement is less, that's why the ladder is not moving. Now the force is here and the distance is increased, but it is not much enough, that's why the ladder is not moving. Now the person is here and the distance is increased. As the distance is increased in enough way, at that time your ladder will create a lot of movement. Okay, this will create a lot of movement. If the movement value is higher, at that time your ladder will slip. Okay, that means to keep in position, we have to use the friction force. Okay, so I can say that the ladder used friction. Okay, ladder used friction. Next one is wedges. Okay, now talking about wedges. Wedges is what? It is used to lifting some heavy weights. It is in shape of trapezoidal or triangular. I'll make two diagrams, like one is this. Okay, one is this. Another diagram is this. Two diagrams. Okay, two wedges are there, and another wedges is like here. I applied a load and I want to separate these two bodies outside. Okay, so at this time this surface and this surface is in contact. Okay, if these two surfaces are in contact, so there should be some resistance force against motion. The motion definition, the friction definition is what? It is a resistance force against motion. Okay, it is a resistance force against motion in contacting bodies. ठीक है, तो two bodies are in contact, that means there should be some friction. If this body is going to downward, okay, this body, I want to make a FBD of this, okay, or you have to make a FBD to understand the forces acting on wedge. So if this is a B, C, okay, I'm going to make a FBD of this. If I'll make a FBD of A, okay, I'm going to make a FBD of A. Now this is our wedge, okay, this is our wedge. It is in contact with B and C. So there is some contacting, normal forces create in contact, like if this is a body and this is resting on this particular surface, then this surface should apply some reaction on this to make it in position, right? So this is N. So this time also there should be some reaction because it is in contact, there should be some reaction. So this reaction is perpendicular to the surface. This reaction is also perpendicular to the surface. If this value is NB, this value is NC, okay, fine. Self weight of this is acting like this, like WA, okay. What other things are acting on this wedge? Friction, because these are the frictions question, and this body is in motion, is try to move, that means a friction will create here, okay. So I know that friction is what? It is a resisting force against motion. So motion किस side हो रहा है? This side, okay. Motion is downward motion. So I can say that the friction will create upward, okay. Resist motion, against the motion it will apply. So I can say that the friction is, just a minute, yeah, okay. I apply a friction, and because this body is moving downward, so I can say that the friction is applied upward, okay. The friction is upward, it's like F, I can see FC, FSC you can write it. Another, this F SB, okay. These are the frictions. So in every body where motion is happening and contacting, what contact bodies are there, at that time what we need, there should be some reaction and contact reaction, and there should be, if motion is in this direction, that means friction is applied in opposite direction, okay. The tendency, if the tendency of block to move downward, that means friction using upward, okay. Okay. So this is a FBD of this diagram. Anything else which left in this? Self weight, okay. Okay. Now this is the FBD of your particular wedge, okay, A wedge. Now you can make the FBD of B also, you can make a FBD of C also, okay. But what another thing that I can do here, because in wedges question especially I can say that we use Lami's theorems, okay. In all wedges question I use Lami's theorem to make it easy. Otherwise what happened here, actually I am going to solve it by equilibrium equation, okay. If I am going to solve it by equilibrium equation, okay, if I am going to solve it by equilibrium equation, then what happened? See, I use Fx, I use Fy, and now I am starting to take our component in x direction, that means component of NB, component of FSB, component of NC, component of FSC. So this will create some confusions because a lot of forces are acting in different direction. We need to take a lot of component of forces, so it make the question tough, okay. So at that time I suggest that you use Lami's theorem. How can I say that Lami's theorem make it simple? See, if I'm not using equilibrium equation, okay, I'm not using equilibrium equation, then what I'm using? Lami's theorem. See, first of all, I recall you what is Lami's theorem. Lami's theorem is, in my first lecture I will discuss about it. I discussed about it. Lami's theorem is nothing. It is simply, if a force is applied, like a P force is there, a R force is there, a Q force is there, that means I can solve it by simply, I can say that the theorem says that the sine of r, the front angle, the front angle, okay, r with a sine of front angle, that means if this angle is theta r, okay, so this is theta r, okay. Again p with its front angle, kya hai? It is theta p, I can say that sine theta p, same as another one q by this angle theta q, okay. So q divided by sine theta q. This is the theorem that is according to Lami's, this theorem it is used to solve the questions, okay. How can I apply this Lamy theorem here? See, in wedges question, I can say that it is a most useful equation, okay. See, a lot of forces are acting in every wedge, okay. At that time, I need to reduce the forces. How can I reduce the force? Understand it properly. There is 1, 2, 3, 4, 5 forces. I can't use Lami's theorem because Lami's theorem says that the forces should be at least maximum 3, okay. The maximum forces should be 3, R, P, Q, okay. And there is 5 forces, so I can say that Lami's is not apply here, okay. But I can apply. See, what I can do, if I'll take a resultant of NC and FSC, and if I'll take a resultant of SB and NB, then these two forces are converted into one, these two forces converted into one, okay. Okay, these two forces converted into one. See, this is a resultant for C and this is a resultant for B, okay. It in some angle, so this angle is angle of friction phi. We know that the angle between the normal reaction and resultant of friction and reaction is angle of friction, okay. We know that in my previous lecture I said that mu is nothing, it is simply is equal to tan pi is equal to tan theta, okay. What is mu? Is coefficient of friction, pi is angle of friction, theta is angle of repose, okay. What is angle of repose? The maximum angle of understand it, if a body is in this plane, okay, body is in this plane and body keep its position, okay, the maximum angle at which the body will fall, okay, maximum angle at which body will fall, that angle is called angle of repose and denoted by theta, okay. So according to this, I know that the angle of friction in between this, and angle of friction I can easily find out if I know the mu, if I know the value of mu, or I have a value of angle of friction. At that time I easily apply, like if the mu value is 0.23, I can find out the phi value and angle is there, okay. And already I find RC and RB easily. Now if I do this, at that time what happened? See, now the question is very easy. Now the question is very easy. See, I'll make this is my wedge A, okay. This is my A wedge. A force RB, a force RB is applied, okay, outside. A force RC is applied, a force W is applied, okay. I can make this diagram. I know that these two forces are resolved into one, these two forces are resolved into one. So there is 3 forces only, RB, RC and WA, okay. Now the forces are resolved into 3, one condition is completed. Now the second condition of Lami's is we have to know all the angles, okay. How can I know the angles also? See, I know the phi value here, okay. If I know the phi value, I can say that, see, first of all this is already in angle. Okay, so we know that angle by question. Okay, there is some angle and then another angle is phi. So the angle is, if this is theta 1, theta b I can say, and this is theta c I can say, it is given in questions. Okay, then the angle with horizontal is theta b plus phi. Okay, it is theta b plus phi. So the angle is theta b plus phi. Okay, here is theta c plus phi. Okay, I know that this angle is, this will make an angle of theta. Okay, you can increase it. Okay, increase it, and okay, so this angle is simply in front angle and this angle is simply front angle. Okay, now WA. Now I have all the angles, I have all the and I have one known force, and 3 angles known by me. At that time I can easily apply a Lami's theorem by putting 90 plus theta b plus phi of sine. Okay, so I can say that RC divided by this angle is what? Sine of 90 plus theta plus phi. Okay, RB is sine 90 plus theta b plus phi. Okay, again W is what? It is 90 minus sine 90 minus theta b plus phi, theta c plus phi, whatever angle it is, some simple like 35 or 45 or okay. This is the process how can we start to solve the wedge questions, and it is easily solved with the help of Lami's theorem, and this is the application of ladder. Okay, also application of friction. So friction used in ladder, friction used in wedges, these two questions are most important question according point of view of AKTU, ladder questions and wedges questions. Okay, now I'll take some questions related to this. Other applications also are there, like rolling friction is there. Okay, rolling friction, when the body is in roll condition like ball, at that time also a friction act. Okay, the next one is clutch. We know that clutch having some brake. Okay, so in clutches also a friction force is there, that's why when we apply a clutch it will stop. Okay, same as in the brakes. Okay, there's also friction. The next one is rolling wedges, friction, clutches, brakes, ladders, wedges. Okay, a lot of use of friction. I mean, many machines, belt friction. Okay, everywhere friction is applied, everywhere. But according to point of view, because this is lecture based on AKTU for AKTU student, so I'll emphasize on ladder question and wedges question, because these two questions are very important according to AKTU. Okay, now our first question related to wedge. Okay, question is determine the force P required to start wedge. Okay, determine the force P. We is talking about this P. Determine the force P required to start wedge. The angle of friction for all surfaces in contact is 15 degree. Okay, angle is already given 15 degree. Okay, this one 15 degree. I can easily solve by what? Either I can apply equilibrium equation or I maybe apply Lami's theorem. Okay, it is a simple question. I can solve it by both. See, first of all, I'll make a video of this one, because the forces are known in this body. Okay, this body have a lot of unknown, because this reaction is also unknown, this friction is also unknown. At that time this is tough to solve directly this wedge. Okay, so whatever wedge is applied with a known force, that wedge is solved in secondly. Firstly I can solve that wedge that have a lot of known forces. Okay, so this is A, this is B, this have a lot of known forces. So I'm taking this one first. Okay, make a FBD. See, the whole game is depend on the FBD. If you are able to make a right FBD, so it is very easy to solve the question, because sigma fx is equal to 0, sigma fy is equal to 0 is easily applied by every person, and Lami's is also very easy. So you can easily apply if you are making right diagram. Okay, so concentrate on the diagram. This is our body, this one. Okay, I understand that this is in touch of this body, so there is some contacting reaction, and there should be some friction. Okay, this is also in touch of this surface, so I can say this is also a rough surface. I can say that there should be a reaction, another a friction force. Okay, see, if there should be some reaction. Okay, now see, if the force is P is applied downward, the tendency of this block to move outward. Okay, if this is moving outward, that means friction is applied to inward. Okay, friction is applied to inward, so friction is applied to inward. Now another, okay, actually this R is nothing, it is a resultant force of Fs that is applied here, and the reaction force, that is N. If this is A, then you can say that it is Na. Okay, so it is the resultant of reaction force Na and friction force that I already described before. Okay, so I'm taking a resultant of this. This is going inward and this is going upward, so there should be a reaction like this. Okay, now I have to decide the angle of this, because in question already given all angles are 15 degrees. See, in question already said that friction for all surfaces in contact is 15 degree. That means friction angle is already given. Okay, so it is 15 degree, the phi value already given. I can say that it is 15 degree from N1. Okay, so this is R1. Okay, now this is already given known forces. I applied here. The next one, we solve this point. Okay, there should be some reaction, there should be some friction. That friction force and reaction is converted into resultant. So there is some resultant with an angle of 15 degree, right? So with some angle of 15 degrees, so it will here. But see, this surface already in some angle. This surface is already in some angle, that is 15 degree. You can see that it is 15 degree. So if I apply the N1, it is in 15 degree, right? I apply a N1, that is reaction force, contacting for reaction force. Okay, so it is in 15 degree. See, if this is a wedge, ठीक है, ये wedge है आपका, ये inward जाने का try कर रहा है. Okay, now a this is our surface, this is our surface. Okay, and this is in contact with this. Okay, so the reaction is like this. This reaction is already in some angle, that is 15 degree. Okay, so this is in 15 degree. Now in question said that the friction angle is also 15 degree. So our R1 is here in 15 degree. Now the total angle is 30 degree. Okay, so I think now you are able to understand the R1. This is our Na. Okay, this is Ra, this is our friction. In this side we resolve the friction and resulting reaction force, and we will take a Ra. Okay, now see, the diagram is 15 degree N1, and this N1 with the friction angle, that is 15 degree. So R3 is applied in 30 degree. Okay, okay, and see here, actually I'm going to solve this part. Okay, we are solving here. Okay, so at this point we see that this is a horizontal, a reaction force is also horizontal in this. So horizontal reaction force, see, N1 is horizontal. Okay, a friction force is this body. If this is going to inward, that means friction force is going to upward. Okay, in this the friction force is upward, so I can make a R2 of this both. Okay, see, this body is going to, in every question we have to understand, first of all, to make a FBD we have to apply the external force first. Okay, if this is some external forces 215. Okay, now it is in contact with some bodies. Okay, so and contacting reaction, it's like in our diagram it is something Na. Okay, this is also in contact here, so this is Nb. Okay, now in every contacting surface, if the surface is rough, at that time a friction is generated. So if the body is going, now this is attached with some friction, so this is force going downward, that's why I understand that this body is having upward. Okay, so this is our Fs here and this is our Fs here. Okay, I'm going to resolve both because if I want to apply Alami's theorem or I want to reduce the forces at that time, what we did, we just take a resultant of both. Okay, and this resultant in some angle, that is angle of friction, this is already given in our question. So our final diagram is what? A final diagram is simply remove this, okay, remove this one, remove this one also. Okay, now this is the diagram that you can easily solve. You know the angle of this, you know the angle of all, that is phi. Okay, this is also in phi angle. Okay, 90 minus phi, or this one is phi. Okay, this is our diagram. So I can easily take a component. If I'm going to solve sigma fx is equal to 0, then what I can do, r cos phi outward. Okay, if this is positive, this is negative, minus 15. Okay, then this component minus r, this is r1, this is r2. Okay, then r2 cos phi, the angle is similar, that's why cos phi. Okay, this is inward, that's why positive, this is outward, this is inward, outward, positive, negative, you can take as your happiness. Okay, now see, if this is inward, I'm taking this side is positive and this side negative, you can take any other. Okay, now r2 cos phi, r1 sin phi, just a minute, r2 cos phi, okay, minus 15 minus r1 cos phi. Any other forces are there? No. So this is our fx. Same as for fy. Okay, if I'm going to making fy, simply 200 downward, if downward negative, upward positive, simply I can take r1 sin phi, r1 sin phi upward plus r2 sin phi upward. Okay, and minus 200 is equal to 0. Solve it, you can easily find out the r1 and r2. Okay, if you know the r1 and r2, I can easily say that simple question that you can understand, the r2 is the resultant. Now I'm taking the sigma fx, sigma fy and known r1, r2. Now come to this, r2 is already known, r3 is only unknown. Apply a Lami's or apply sigma fx, sigma fy. I already discussed about the angle, so I think this question is simple now to solve. Okay, the last question is related to ladder also. This is also a simple concept. Just a minute. Okay, a ladder concept is also very simple. See, a ladder is 6 meter long length. Okay, has a mod of 18 kg, that is always act in center of gravity Cg. Its center of gravity at 2.4, that means it is applied here. Okay, from the bottom the ladder is placed against the vertical wall, so that make an angle of 60 degree. This is 60 degree with ground. How far up the ladder can 72 kg man climb before the ladder is in the verge of slipping? Okay, we need to know the distance where 72 kg is the position where 72 kg is take position when the this ladder is going slip down, okay, is going to slip. At the verge of slip, we need to find the x, okay. So I assume that this is at x distance where the body is start to slip, the ladder is start to slip, okay. So the diagram is simply the center CG is having its cell weight 72 kg at x, 6 meter total length. It is in contact, so there is a reaction. It is a rough surface, so there is a friction. The ladder is going to slip downward, that in it is outward, this is downward, so friction force is upward and friction force is inward, okay. Now the contacting force, contacting reaction NB, this is Na. Now simply first step is draw the FBD. Another step is using equilibrium equation and find the unknown forces. Using equilibrium equation, there is two type of question. If you know that all the distances and angle, firstly apply summation of moment, okay, then resolve the things. If there is a unknown distances or angles, at that time you firstly use sigma fx or sigma fy, okay. This is question practice resultant, nothing else. Now see, all the things are given. Phi already given, that 15 degree angle of friction, so I am taking mu directly. Now sigma fx is 0, sigma fy is 0, vertical force is summation, horizontal force is summation, the Na value putting in this, and now Na and B is known by sigma fx, sigma fy. If Na and B known, we know that friction force is nothing, it is mu n, multiply it and find the value of friction forces also. Now the three equilibrium equation are there, one is sigma fx, another sigma fy, the third one is summation of moment. Apply the summation of moment to find the x. Nothing else, take a moment at A or at B, okay. Summation of, if I am taking the moment at A, I am taking moment at A, C, NB multiplied by perpendicular distance is 6 sin 60, okay. The FB is what? Horizontal distance, FB multiplied by 6 cos 60, okay. Another, the 18, see this will make a anti-clockwise. If anti-clockwise you are taking positive, then clockwise is negative. This will take anti-clockwise, this will take anti-clockwise, both are positive, okay. Now this will take clockwise, this will take clockwise, both are negative, okay. See, clockwise positive, anti-clockwise negative. Solve this and find, you see that the unknown distance is x only, it is directly we can find out, because one unknown, one equation, I can easily solve it. These are the question that is related to ladder and wedges. This is very important for in terms of AKTU, okay. If you are going to give exam of AKTU, you have to understand these two questions, question of different type, but these two concept, one is for wedge, another is for ladder, okay. If you have any question, give in comment. Thank you so much.